way of solving problem is closer to the real world way of solving problems. It's much closer to the real world way of solving problems. And in real world also, problems are solved by collaboration. In real world, we'll find problems are solved by collaboration. To understand this, yes, that there is collaboration to solve problems in real world and to associate it with object-oriented way of solving problems, fine. Let's take a simple problem from the real world. Okay, how it is being solved. Fine. So our problem here, a very simple problem here is, we want to send flowers to our friend who is in Kolkata. Okay, let's say we want to send flowers to our friend who is in Kolkata. So, yeah, how do we go about it? We are looking at interactions now. What are the various interactions which are taking place? You have to give instruction, right? Yeah, basically interacting or giving instruction, you're operating, yeah, okay. So, yeah, how do we go about solving this problem? You have a friend in Calcutta and you want to send flowers. Okay.
Somebody who wants, like some shopkeeper who have reference over there.
Okay.
I can go to that shopkeeper and
yes.
ask for his reference.
Okay, so let's go do that. Let's do this. Okay, so what do we do is, okay, so here, fine, you have to use some actual things, right? So let's say what we do here is we go to the JK Florist. Fine, we got someone called JK Florist. So we go to, that's our JK Florist. Okay, and we interact with JK Florist. What is the interaction you have?
I want to send a flower to this particular.
So your instruction is?
Send a flower.
Send flowers. Okay, send flowers. Yeah. When you say send flowers, what is the associated information you will supply? Okay, you want to give address and phone number of the friend where it is to be sent. Okay, so that information. Okay, what else? The kind of flowers to be sent, the quantity of such flowers. Okay, so fine. You have this message, you have your interaction with JK Florist. Send flowers, give the information associated with this. When you do this, what will JK Florist do? How does he go about solving this problem further? Oh, he got this instruction from you. So now what's his, how does he go about this? What does he do now? What does JK Florist do? He looks at the name and address first. Oh, this address is not a local address. Right? It's a different, right? It's the same instruction someone else will also give. I want this, but that's a local one, but this is not a local one. So there's a difference. When it's not a local one, now what he does when he finds not a local one? He refers to a diary. He has a diary where he manages city-wise. Oh, this town, that's a contact person. This town, that's a contact person. So he has his own diary, right? He has a diary which he'll look up, and then he is able to manage a contact in Kolkata. Let's say we have some contact here in Kolkata. Let's call him as, so this guy is KK Florist. Okay, so now, yeah, he's found that there is some KK Florist. Now what's the next step he does? Now he interacts. JK Florist has an interaction with KK Florist. What is the interaction?
Send flowers.
Send flowers, yes. He is interacting and saying send flowers. Specifies the information which is related to sending flowers. Okay, fine. KK Florist receives this instruction. How does KK Florist proceed? Same way. First thing, look at the name and address. But here, oh, it's a local address. For him, it's a local address. So if it's a local address, okay, I can proceed further. I look at the type of flowers. Okay, so what KK Florist is doing is he's looking at the type of flowers and then says, oh, this type of flowers, oh, I have a flower producer who does them, who produces them. Fine. So he interacts with a flower producer. Okay. So here is our flower producer. Let's say some flower producer is there, and he interacts. What is the interaction with the flower producer?
I want this flowers and the quantity.
So he says, get flowers. When he says get flowers, he'll specify the quantity, the type of flowers and the quantity. Fine. He gets those flowers, right? He's got the name and address. He's got the flowers. Now what's the next step he'll do?
They will transport the same flowers to a friend, that particular person.
How? How does he get them?
Well, it's everything himself.
Oh, he will lose business because there is no one at his shop. So what he does is he interacts with a delivery boy. So there is some delivery boy, okay, and he has an interaction with the delivery boy. What is the interaction?
Send.
When he's interacting with the delivery boy, not the information, I'm saying what's the instruction? What is the send flowers? Delivery boy is able to deliver anything. He says deliver. Right? It's a delivery boy. So the interaction will be, oh, deliver. And what will give? The name and address, the contact details, and the flowers. It could be any other thing. Fine. And what the delivery boy will do? He'll go and then deliver it to your friend. Okay. So in order to solve a problem, there's a lot of interaction which takes place. And it's done by collaboration. Then there's collaboration. Fine. Let's come to this first one. You went to JK Florist and said send flowers. He understood send flowers. Why? Why JK Florist could understand send flowers?
Because he does the business.
You go to Mochi and say send flowers. Will he understand? No. Why does JK Florist understand send flowers? Huh?
Flower platform.
He understands because he is a florist. He is a florist. Florist will understand send flowers. Fine. See, JK Florist is a florist. He is of type florist. Class. What is JK Florist? What is florist? What's the relation between JK Florist and florist?
Florist is a
Class. And what is JK Florist?
It's a type.
Object. The instance of that class. What is KK Florist? Instance of the class. Clear? This is object, the actual thing with which you are interacting. But anything which you are interacting is of a particular type, is of a particular category. Fine. And that is what is a class. Class is nothing but a type, simply a data type. Fine. Okay, fine. And you can understand here, because it's a type called florist, it has a fixed set of interactions which can take place. Send flowers, oh, florist, okay, if it is florist, these are the things which a florist should be able to understand. These are the interactions available for the type florist. You do interaction on objects. Objects are of a particular type. and the type decides what it should be. Nothing different from the earlier thing. You have the type called int. If anything is a int, you can do addition, subtraction, multiplication, division, modulus. If something is a boolean, I can do certain things. It's same. There's nothing new. Only thing is the type is programmer defined. The operations are defined by the programmer. You identified the operation called send flowers from the real world. You have your abstraction. This is what we call as abstraction. You created an abstraction. By looking at things in the real world, you thought, okay, I should have a type like florist in which I should be keeping these things. Clear? Fine. So class and okay. Now coming more fine. Let's talk of a few more things. One thing is we are now clear with class and object, the relation between class and object. Object is an instance of a class. Fine. That's a relation between them. Okay. Now another thing further. You went to JK Florist and said send flowers. Now you can also interact with JK Florist, which is related to the commercial aspect, saying, okay, because of the service, get me a bill. You can ask for a bill. That's another interaction you'll have. You'll ask for, okay, accept this payment. These kind of interactions, which are saying, get me a bill, accept a payment, these are the interactions which you will have even with Mochi. He is also giving some service. All those shopkeepers, it's an instruction which is understood by shopkeepers. Oh, but what is florist? Oh, florist is a shopkeeper. Fine. Our grocer, he's also a shopkeeper. Also, he understands these interactions. So we got actually a still bigger thing called shopkeeper. I'm going other way around. We got a shopkeeper. Right? A shopkeeper will understand certain things. And when we talk of JK florist, JK florist we say is a florist, but florists are shopkeepers. Fine. So florist will understand, any florist will also understand anything which is available for shopkeeper. We have interactions which are defined for a shopkeeper. Fine. So our JK florist is able to understand not only things which are meant for florist, but also for shopkeeper. Fine. Oh, you can go to JK florist and say, how are you? He understands how are you. Not just because he is a florist, not just because he is a shopkeeper, but because he is a human. He is a human. All humans understand how are you. And it's an interaction available for humans. What we are saying here is supertype subtype relations. Human is a supertype. Within humans, there is a specialization called shopkeeper. Whatever are interactions, whatever a human can understand is understood by shopkeeper. Fine. Whatever shopkeeper can understand is always understood by a florist. This is what is inheritance. Supertype, subtype. Fine. See, subtype has more functionality compared to the supertype. because it inherits functionality from supertype and has additional functionality as well, can add more functionality. Clear? So when we talk of object-oriented programming, it's about understanding supertypes and subtypes. And of course, this concept was already there. You talk of int, you talk of a long. Long is a supertype, int is a subtype. With long, you can do certain operations, right? You can do certain operations which are available for long. But when I say int, of course, whatever you can do with a long can always be done with a int. Those operators are available for int. With int, you can do more things. Or you even have the increment decrement operator. In case of C language, you don't have them for long, but you'll have them for int. If someone writes a function and says, okay, oh, this function requires a long value, right? You can always pass an int and say, fine, because anything which is available for long, fine, how this function has been written, the function is using long for that variable. If I use a int, whatever I am doing for long is available for int, and therefore int could always be used. Supertype subtype relations are existing even with the earlier data types from the language. It's nothing new. Fine, inheritance was there. Inheritance is just about supertypes and subtypes. Fine, a subtype inherits operations from the supertype, can add more operations. Okay, fine. So that inheritance concept was existing. Yes, when we create a new data type, right, we can inherit from some existing already created data types. That ability is nothing but inheritance. So the object-oriented programming language allows you to create your own data types where you can derive from existing types also. Fine? Okay. So you had this, fine. Let's use those. What are the terms we have understood? Inheritance. Okay. We have understood about what is a class, what is object. And when I was talking initially, abstraction, what is abstraction? It's a process by which you are actually identifying the types. Fine, you identified that there's something called florist. What operations must be available on florist? The process of identification, this is what is known as abstraction. Fine? Don't link it with the keyword like abstract. Okay, the concept abstraction is like this.
It's like wrapping something.
No, it's just like modeling. It's more closer to the. You create your own model from the real world. You have your abstraction. Fine, you think from the real world. Oh, you want to solve this problem, and you think about types, categories. If this category, if something is of this type, okay, this is what should be the operations available. You are doing that process, right? That is what is abstraction. Fine. Because of abstraction, you are actually being able to define classes. Fine, and put the methods in them. Okay. Fine. Then we have the inheritance. Then another thing which is to be supported is data encapsulation or data hiding. Okay, let's understand data encapsulation. In that real world example here, when we interacted with JK Florist, we said send flowers. What did he do? How did he begin?
We look for the instruction and then look for his diary.
He looked into a diary, right? That diary, is it available to us?
No,
If it was available to all, what would happen?
we would have contacted directly.
Okay, what else? That's not as dangerous. There's something still more dangerous. If the diary is available to all, fine. The read part is not that dangerous. It's about, you're talking about reading from the data from there. You can read the data, that's good. Okay. Sometimes you might even ask, okay, do you know someone there? And he might oblige you and say, okay, fine, I'll tell you the name. And he might give you the name. That's okay. But what's more dangerous is if the diary, anyone can go and make any entries in that diary because it's openly available. No, we don't like that, right? Then the sanctity of the diary is lost. Who knows who has done what, whether those entries have to be believed or not, right? Yeah, so we find in real world we never have, find we always have our personal thing. That diary he won't share. Right? He might share information from there, but no, might not give you. So you can say you can interact and get information out of the diary by interacting with him. Okay, so you have your data structures. Diaries are data structures. You have your data structures which are encapsulated. Fine, you have to interact with the object in order to get the information from the structure. Okay, fine, that's what the data encapsulation is about. Fine. Here's your data structure. It is encapsulated by code. Have your interactions, have some instructions. Say, okay, you get me this, fine. You say, okay, you can make this entry, he'll verify and then put the entry. But you can't make the entry directly. Fine. You can ask him to make an entry, he'll verify the things and then, okay, how reliable you are to him, fine, how much he trusts you, fine. All such things will happen, right, in real world. But no, he'll not give his diary to you. That's data encapsulation, right? Real world also data encapsulation exists. Fine. And then one more thing, from object-oriented programming point of view, we have is the polymorphism. Yeah, what is polymorphism? Okay, there are many types of polymorphism. From programming point of view, there are two terms more popular. Okay, for polymorphism, there are two terms which are more popular. One is overloading and other is overriding. So these are different types of polymorphism. Okay, these provide different types of polymorphism. Okay, overloading. Okay, let's consider overloading. Both have to be considered. Fine. So when we look at overloading, yeah, example for fine, a simple example for overloading can be like this. Let's consider that we have a plotter here. Fine, there is a plotter object. Fine. The interaction with the plotter, what is the interaction with the plotter? You can ask it to plot various kinds of things. It will go and plot the things, right? So your interaction can be, you can say draw a line. When I say draw a line, I'll specify the starting point and the ending point, 2 points. It goes and draws the line. Then someone says draw a circle. Fine. So when someone wants to say draw a circle, yeah, what would he give? Okay, he gives a center point and a radius. Okay, so when he gives the center point and radius, fine, this can go and draw a circle. Fine. Now someone else has 3 points in a plane, and we know there's a unique circle which goes through 3 points in a plane. So when someone has 3 points in a plane, what he might have to do now in order to interact with the plotter is he'll have to compute from the 3 points, he'll have to make a computation of center point and radius, and which is a very standard way, right? There's a standard mechanism of, oh, given 3 points, how to compute center point and radius. And suppose if he makes a mistake in that, he'll still blame the plotter. That plotter is not correct. And it may be his mistake, right? So no, what we can have here is we can have one place to have mistakes rather than everyone having possibility for everyone to make mistakes. Okay, so that it can be corrected at one place. Okay, it's not that we are saying, oh, there can't be mistakes. Okay, so what we have here is we can add another draw circle which takes three inputs, 3 points in a plane. So given 3 points in a plane, I'll be computing it and I'll be using that draw circle. You can work by just giving me the 3 points. I'll take care of the computation part. Fine. So there are two different ways of doing a draw circle, two different sets of inputs. Fine. Fine. So this is what overloading is. Fine. The overloading is something related to this. And then if we talk of overriding, for overriding, at this moment, not a very great example, but just conceptually if you want to understand. Okay, let's continue with that same example of florist. Now, we can have an interaction with florist. All humans understand, how are you? Fine. But then when you go to a shopkeeper and say, how are you? Okay, what he might do is he might be extra friendly. See, there is a normal behavior for all humans. For humans, if someone says, how are you? This is how he's supposed to work. He's how he's supposed to respond. That's one normal thing. Right? But when we do it for a shopkeeper, the shopkeeper becomes extra friendly, keeping in mind that, oh, he is a probable customer who will be coming to me. Fine, wants to be extra friendly. Okay, fine. So what is happening here? It's the same interaction called how are you, which was available for the supertype. The subtype is doing it differently. Same interaction, but he does it differently. This is what is overriding. Exception to the rule. All humans, that's one normal thing. But in this special case, this thing has to be done differently. It's an exception to the rule. Clear? Okay, so fine. So this is about polymorphism. Fine. Overloading, overriding. Fine. So object oriented programming. Fine. We understand what is object oriented programming.